All right, this one's for pre-calculus. 7-3 is the unit. 7-3, the graphs of the sine and the cosine functions. Just the basic look of what the graphs look like. So there's a graph that goes with trigonometry. This is a big deal with trigonometry. Usually, one or two multiple choice questions, an SAT, ACT, college placement exam of any type that they want to see what kind of math class you should be taking. So this is section 7-3 is what I call it. It's page 13. All right, it's page 13 in our note packet. Sine and cosine functions. So it ties into what we know about the unit circle. It does tie into that stuff. So let's fill in the coordinates and the given radian values. The coordinates and the given. Let me make sure this is on focus right away. Let me refocus it. There we go. 0, 0 would be the origin of it. We have our unit circle. The radius is equal to 1. So if you go straight out here, the coordinates right here is 1, 0. 1, 0. Remember that the x values deal with the cosine. The y values deal with what's your sine answer. Okay? So if you're starting on your unit circle, you start at 0. If you go all the way around, notice it's in radians, we're at 2 pi. When you go straight up above, you're at the length of 1. That would be at 0, 1. Keep in mind, if I ask you what's the cosine of pi over 2, cosine of pi over 2 is the x value. What's the sine of pi over 2? The sine is equal to 1, and so on and so forth. If I ask you, hey, what's the sine of 2 pi? The answer is 0, because that's the y. If I ask you, hey, what's the cosine of 2 pi? The answer is 1. It's the x number. All right, same thing here. This is at -1, 0. Remember cosine and sine. And 3 pi, it's kind of look a little funny. Let's draw it a little different. 3 pi over 2 is at 0, -1, but the similar idea carries around. X and y, cosine, and sine. Oh, and I'm probably getting ahead of myself right here in this sentence. Remember, the sine is always the y coordinate, sure enough. And the cosine is always the x coordinate. See, it helps if I actually read the notes ahead of time rather than repeat myself like that, but hopefully it sinks in for you a little bit. All right, so now we got to make a graph of it. And what they're going to do is make a graph out of these points, but they're going to do it linear, like what we normally see. If I ask you to graph y equals mx plus b, you get a straight line. There is a certain look of the so-called sine and cosine graphs, the sine and cosine graphs. It says graph y equals sine x, all right? Our x-axis will have these points. It'll have 0. It'll have pi over 2. It'll have pi. It'll have 3 pi over 2, and then it'll have 2 pi. Okay, that's what we're going to put on the x. So it starts at 0, and then evenly space these out. So it's pi over 2. Then it's going to be pi. Then it's going to be 3 pi over 2. 0 is at the y-axis line. And then it's going to be at 2 pi. And what happens is, for the sine graph, if y equals sine x, you're plugging in these numbers for x, all right? Or later on, they might use theta, all right? But you're plugging those numbers in for x. So if I plug in 0, what's the sine of 0? The sine of 0 is 0. So we put a dot at 0, 0. What is the sine at pi over 2? Let me lower this a little bit. What is the sine at pi over 2? Well, it equals 1. We're going to make 1 up here, and we put a dot. What is the sine at pi? It's the y value. That's 0. And what is the sine at 3 pi over 2? Now we're at -1. And that would be here for a dot. All right, plug in 3 pi over 2, go down to -1. And then if you plug in 2 pi, put in 2 pi here. Sine of 2 pi, the answer is going to be the y value is 0. And what happens is then it just repeats itself, and the curve just has this look, and then it'll go back up to 1, down to 0, down to -1, back up, down. It just keeps going and going and going. It repeats itself. But they call this, draw it like a little arrow as if it keeps going, but they call this the sine curve. Oop, I missed my point. All right, the sine curve. It should look a little more even than I did it. The very top should be the top of the bell, top of the curve. This should be the bottom of the curve. I did a good job with this one. Not so hot on this one. It looks like I'm off center a little bit. This graph is sort of like the period of how long it takes for one whole revolution. We'll get to that. Actually, I'll do it right now. So your domain is your x values. All right, my domain is all real numbers. I'm plugging in radians, but I'm using the pi symbol. But I could plug in negative numbers. I can plug in positive numbers. It'll just continue to make this curve. I can plug in anywhere, keep going to the left. I can go to infinity on the right. I can keep plugging in numbers. The range, on the other hand, only reaches a max of 1 and a minimum of 1. So the range for the y values, all right, the y values go from the lowest is -1, and it reaches a height of +1. And we've done domain and range a little bit. We got to use those brackets. The lowest number it hits is -1. The highest is +1. The period is how long from start to finish does it take that kind of a shape before the curve repeats itself, before it starts going back up to 1 and down to 1, before it repeats itself. So from here to here, sort of box that in like a window. That is my period, and it goes from 0 to 2 pi. It is 2 pi in length. Cosine and sine have the same period length, 2 pi. Period is how long, all right, how long to complete one cycle. Did I misspell cycle? I think I did. Cycle. One cycle of the graph. Of the graph or of the curve before repeating itself. All right. How long to complete one cycle? Sorry, I misspelled cycle. One cycle of the curve before it starts repeating itself. So it starts at 0 and it goes up, comes back down, then it goes down, turns, comes back up, but then it would repeat itself. It would keep going and going and going. And later on, we're going to stretch it left and right. We're going to shift it up and right. We're going to do translations of it, similar to what we did in the very, very beginning of our pre-calculus here. All right. And most pre-calc teachers recognize that it goes 1, then 2, and then usually the number 3 comes next. All right, little small typo. All right, we make mistakes. All right, so y equals cosine x. Let's get the circle back in here. All right, cosine is your x number. So now if you plug in the same point, 0, we're going to plug in 0 for x. We're going to plug in pi over 2 for x. We're going to plug in pi, just going around. Different angles that we plug in to find the sine of. 3 pi over 2 and 2 pi. And then it'll start repeat itself as it goes around. Kind of like if I gave you, hey, what's the cosine of 270 degrees? And then I said, hey, what's the cosine of -90 degrees? Well, you're at the same spot. So that's why it just kind of repeats itself. All right, they're coterminal angles. That's why this would just keep repeating itself. You'd keep going around the circle and getting the same answers. This one starts out a little different because when you plug in 0 and you say, hey, what's the cosine of 0? The answer is 1. It actually starts this graph up here. So this period, the cycle of this period, it starts up at 0, 1. When you plug in pi over 2, the answer is 0. Now we're here. When you plug in pi, the answer is -1. Now we're down here. When you plug in 3 pi over 2, the x value is 0. When you plug in 2 pi, you're back up to 1. And it has this kind of a look. I'll draw a little arrow here. Bottoms out here, comes up here, tops out here, turns. So I don't want to look like I'm passing through that point and I keep going up. That's the top of the little curve. Now the period that we're talking about, the period is here. This little window right here cuts off right here. All right, that is one cycle where it starts here, goes here, and then it would repeat itself. It would look from this point forward, it would just repeat what it's doing here on this little roller coaster of a slide. All right, so what is the domain going to be? So the domain, I can plug in any numbers, negative, positive, left and right. So again, it's all real numbers. All right, all real numbers you're allowed to plug in. The range, the highest number is 1. The lowest number you can get on y is -1, and that's going to continue on that curve. So it goes from the lowest is -1, and the highest number is 1. Brackets means it includes 1 and -1. And the period length, it goes from 0 to 2 pi before it repeats itself. And so that's a length of 2 pi. It's a length of 2 pi. Now, when we're doing all this, these are some key points that we got to keep in mind. The key points for this graph, are these 5 angles going around, repeating 0, I guess, but it's 0, then it's pi over 2, and then it's pi, and then it's 3 pi over 2, and then it ends at 2 pi. And that's the key points when we start to shift this stuff around and move it. We can move it up, we can move it down, we can stretch it left and right. All right, how tall it gets, how small it gets, these little humps, we can change it. That's called the amplitude. We're going to talk about that. We can change the period length of how long it is before it does a repeat of the cycle. So that's all part of the second page of notes. I'm going to get a little head start on it before I start the second video, I think. Let me get a head start on it. All right, you're going to learn about transformations which affect the amplitude and the period of a trig graph. So they call these the trig graphs, and we're doing the two basic. We're doing sine and cosine. So the amplitude is how tall or how low the graph goes. All right, think range, the y values. How tall will those loops be and how low will those loops be, all right? There's sort of like a middle line that goes across, and then it goes so much above that. Right now it's just going up 1 and as low as down 1, but we can change that, all right? And then the period can change. Instead of starting at 0 and 2 pi, it might start at 0 and go all the way to 8 pi and have a real stretched out sort of a look, and we'll talk about how does that happen. The amplitude changes for sine and cosine is if you multiply out in front of sine and cosine, then the amplitude will change. If you multiply with x, now it'll usually look like, it won't look like parentheses. It'll almost look like it's together with the x. It would almost look like this rather than a b times an x. But if you multiply with the x, not in front of sine, not in front of cosine, but with the x, then that's going to change the period length on the inside of this. Okay? The first examples, I should say, are going to deal with changing the amplitude. And the bottom ones, we're going to change, because it's a multiplier with x, we're going to change the period length. Now here it's going to change. It's 1/2 times x. Think of it as 1/2 times x. And this one's going to be the number 3 times x. What does that do to the period length? We're going to pick up on that in video number 2. I'm going to pause it right here.